Hi everyone, welcome back to our channel. In previous videos of this chapter, we have discussed how to find the maxima and minima of a function with two variables. Now we are going to discuss how to find the maxima and minima of a function with three variables named as x, y and z. We have a special method to find the maxima and minima of a function with three variables, which is known as Lagrange's method of undetermined coefficients. This is also simply known as Lagrange's method. Okay. So first of all, I will explain the procedure how to find the maxima and minima of a function with three variables by using this method. Okay. See. Suppose we have to find the maxima and minima. The maxima and minima of a function f of x, y, z. Already know that a function with three variables is simply represented by f of x, y, z, subject to the condition. Subject to the given condition is g of xyz is equal to 0. Then we can use the following steps. Okay, so all of you please remember that one important point is, suppose we are going to find out the maxima and minima of a function with three variables. Surely they will provide you a condition in the given statement of the problems. Suppose function has three variables and condition is not given in the problem, we are unable to find out the maxima and minima of a function when function has three variables. That is the most important thing. Surely they will provide you a condition. With respect to that condition, we are going to find out the maxima, otherwise minima of this function. Okay, please remember that point. So step 1. First of all, we have to write the Lagrange's function. Lagrange's function of given two functions. You can take the f of x, y, z as equation number 1 and the condition as equation number 2. Lagrange's function of 1 and 2 as below. Okay, the Lagrange's function of these two functions is represented by f of x, y, z. It would be first function f of x, y, z plus lambda into g of x, y, z. This is the condition. Okay. In this way, we have to write the Lagrange's function. Some of the people called as auxiliary equation also, as you wish. Okay. Mostly Lagrange's function name is popular. Step 2. So for stationary points, otherwise for maxima and minima, we should equate first order partial derivatives to 0 of this Lagrange's function capital F. For stationary points, we should take dou f by dou x is equal to 0, nothing but partial differentiation of f with respect to x is 0, dou f by dou y is equal to 0. Okay, and finally dou f by dou z is equal to 0. So here we will get three equations. Okay, here in the Lagrange's function, lambda is called Lagrange's multiplier also. Okay, by each equation, otherwise from each equation, find find the value of lambda. Find the value of lambda. Okay. From this equation you can get the value of lambda. From this equation you can obtain the value of lambda. From the third equation also you can obtain the value of lambda. So you will have three values for lambda and equate them in each case. Okay, first of all we have to write the Lagrange's function of given function and the condition like this. After that we have to take the partial derivative of this Lagrange's function capital F with respect to x, y and z and blindly equate them to 0, otherwise we can't get the stationary point, we can't get the maximum and minimum also. Okay, so from these three equations, from each equation obtain the value of lambda. So here you will get a lambda value, here you will get a lambda value, here you will get a lambda value. So all lambdas are same, that's why we have to equate lambda values here. Okay, also by using condition 2, we can get stationary point. So I will say that stationary point as A, B, C. It means that small x value is small x is A, y is B, z is C. After getting A, B, C as stationary point, you can substitute this stationary point in the given function. So you will get the maximum, otherwise minimum of that function. Okay, that is the final step. So finally, substitute this is stationary point A, B, C in 1. So we will get the extreme value. Already you know that extreme value means it may be maximum, otherwise minimum of the given function. Value of f at a ABC. Okay, so this is the limitation in this Lagrange's method, because this Lagrange's method does not give the conclusion. The final answer is either maximum, otherwise minimum exactly. But whenever three variable function problem is involved in the statement, they will give the answer. Maybe they were asking as find the minimum, otherwise find the maximum for this function. Okay, from that statement we can blindly copy the result. Okay, that is the concept of Lagrange's method of undetermined coefficients to find the maximum and minimum of a function with the three variables. I will give the examples and practice problems from next video onwards. Please see carefully. Thank you very much.